So what we're going to do is we're going to take the previous concept now that dealt with square roots, and we're just going to adapt it. So now we're dealing with rational exponents. So instead of seeing the square roots, you're going to see them become rational exponents, which basically just means fractional exponents. So rational numbers are all numbers that can be expressed as a fraction. So a rational exponent is an exponent that's a fraction. So just remember, the square root of x is really x to the 1/2. The third root of x is really x to the 1/3. The third root of x squared is really x to the, notice, the index has always gone in the denominator, so this is x to the 2/3. So we're going to be asked to write in radical form, you're going to be asked to write in rational exponent form, and then you're going to be asked to evaluate. So if you're asked to write in radical form, we're going backwards. So if I say x to the 1/7, well, that's the same thing as saying the 7th root of x. If I say z to the 1/3, that's the same thing as saying the 3rd root of z. Now, starting with the radicals and going to rational exponents, the square root of w is w to the 1/2. The 5th root of b is b to the 1/5. Now, when you're asked to evaluate, that means to simplify. So we know the rule for a, you can't have negative exponents. So step 1, I'm going to move that to the denominator. Step 2, I know now with rational exponents that when something's raised to the 1/2, that really means square root. And lucky for me, the square root of 49 is a perfect square for 7, so I end up with 1/7. For 32 to the 5/2, that means the 5th root of 32 to the 2nd power. Now, you can certainly figure out what that is, but there's an alternate way that you can write that. You can write it as the 5th root of 32 and then raise that to the 2nd power. Again, I'm going to star this one just because that's the one I always prefer because it drops the number dramatically. So the 5th root of 32, well, 32 is made up of 5 2's. So that's a perfect 5th root. So this is really just saying 2 squared, which is equal to 4. And that's your final answer for that. So for any real number, b, I am going to, so it says these are all different ways of writing the same thing. And I know that might look confusing, so I'm going to give you an actual number here. So if I give you 27 to the 2/3, well, 27 to the 2/3 is the same thing as saying, using our rules of exponents, 27 to the 1/3 raised to the 2nd power. Or I could say 27 to the 2nd to the 1/3 because, again, both of those last two, we multiply the exponents together. In terms of radical form, this is the 3rd root of 27 squared, which is the same thing as the 3rd root of 27. Whole thing gets squared, which actually gives you a final answer of 9. So this is 1, 2, 3, 4, 5 different ways of writing the same exact problem, and the final answer is equal to 9. So when we simplify expressions with rational exponents, we use our radical rules. In terms of, or not radical rules, we use our exponent rules. So when we're multiplying with the same base, we add the exponents together. So we get y to the 1/7 plus 4/7, which is y to the 5/7. And you leave it like that. You don't make it into a radical. X to the negative 2/3, we can't have a negative exponent, so we drop it to the bottom. We're just simplifying and making them positive. Now, an expression with rational exponents is simplified when there's no negative exponents, there's no exponents that are positive integers in the denominator, it is not a complex fraction, the index of the remaining radical is the least number possible. So we're just going to go over 4 instances here. So some of these can be a little tricky too, so we're going to sort of it's like a puzzle trying to rework some of these. So we have 6 root of 16. So that's the same thing as saying 16 to the 1/6. 3rd root of 2 is the same thing as saying 2 to the 1/3. Okay, so what we're going to do is we're going to start simplifying more. Well, 16 is 2 to the 4th, raised to the 1/6 power. I'm trying to get it so we have the same base here. Now, what I can do is I can multiply these exponents. So I get 2 to the 4th sixth and 2 to the 1/3. And 4/6 is reduced to 2/3. So if I have 2 to the 2/3 over 2 to the 1/3, now what I can do is I can subtract. So here I multiplied, and here I can subtract. And when I subtract, I get 2 to the 1/3, or we can say the 3rd root of 2. Either option for that one. All right, for the next one, so we have 4x to the 4th to the 1/6 power. So let's break it down. So 4 is 2 squared to the 1/6, x to the 4th to the 1/6. Now if I simplify, I get 2 to the 2/6, x to the 4/6, 2 to the 1/3, x to the 2/3. So now if I put this underneath a 3rd root here, I have 2 to the 1st, and then I have 2 x's left over for that. For C, y to the 1/2 is the same thing as saying the square root. So this would be the same thing as the square root of y plus 1 over the square root of y minus 1. So that's not okay. So I have to multiply by the conjugate of the denominator. So when I do that, square root of y times square root of y is y. Square root of y and 1 make radical y. If I keep going with FOILing, there's my numerator. Denominator plus radical y minus 1. So I get y plus 2 radical y plus 1 over y minus 1 for my final answer for that one. If you want to leave it in 1/2, that's fine as well. All right, for D, let's rewrite. So I get 81 to the 1/8. I get 3 to the 1/6. 1/6. Well, 81 is 3 to the 4th to the 1/8. I'm trying to get it down to have that same base, and I have 3 to the 1/6. So when I multiply these guys,